Hi, this is Mrs. Ziegler, and I'm going to go over this making ions activity that is done in class. Now, if you're doing this at home, you can actually draw this on a piece of paper or whiteboard if you don't have access to a printer or to beans in order to actually do the actual activity. This is to help those students to visually see how we get this information. All right, so in this activity, you are going to complete the pre-lab questions. We'll do this in class. So you need to know the definition of an ion. An ion, remember, is a charged atom. It's an atom that has more or less electrons. All atoms want to have full electron shells, full valence electron shells. Again, valence electron shells are the shells farthest away from the nucleus. The octet rule states that almost every atom has a full valence electron shell when it has 8, again, the octet rule, in its valence shell. Hydrogen and helium follow the duet rule, which states that they have a full valence shell with 2 valence electrons. This also includes boron, beryllium, and lithium. Okay, so atoms will gain or lose electrons to have a full valence electron shell. If an atom blank electrons to have a positive charge, well, again, to have positive charge, you're going to lose electrons. If an atom blank electrons, it will have a negative charge. So again, if I'm going to be negative, that means I'm going to have and gain electrons. Positive ions are called cations, and negative ions are called anions. Valence electrons, again, are electrons in its outermost energy level. This is all from information that was reviewed in class. All right, so now we're going to follow the directions for the activity. So if you are not paying attention in class and you're going over this in the video again, you are just going to read through in order to complete this activity. So the first thing is that we are going to find the number of protons and electrons and complete our sheet. Then we're going to go to our sheet and arrange the electrons based off of what we learned for Bohr diagrams. And then from there, we can figure out the number of valence electrons. So in class on this Bohr diagram, we are going to put our electrons, which in this case are beans, but on the slides, we're using these as our electrons to complete this chart. So we're going to start with oxygen. So oxygen on our periodic table has an atomic number of 8. So therefore, the number of protons is 8 and the number of electrons are 8. So now we have to figure out the number of valence electrons. So we're going to arrange our electrons on our Bohr diagrams. Again, we have 8 electrons total that we're putting on here. So we start with the first energy level. I put 1, 2. I max them out. So then now I have 2 electrons. I have to do a total of 8. So I'm going to put the rest. So that's 3, 4, 5, 6, 7, 8. Now, if you notice, what I did was I put them around the ring until one at a time until I can start to double up. Okay, so now when I count, I see that I have my 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now, I'm going to record the number of valence electrons. The way that I figure that out is I find the outermost shell. Well, the outermost shell in this case is the second energy level, and I count 1, 2, 3, 4, 5, 6. So on my chart, I'm going to write 6. The next question, it says in the column, it says, will the atom gain or lose electrons? Well, I go back to my paper. It says, will the atom gain or lose electrons to get a full outer shell? Well, here's your rule of thumb. If I have 5 or more valence electrons, the atom will gain electrons to get a full valence electron or valence shell. If it has less than 5, the atom will lose electrons to get a full valence shell. Now, to understand why this happens, so again, knowing this, I have 5 or more, I have 6 valence electrons, so therefore I know it's going to gain. The reason why we know this, or the reason for the understanding, is because if I have 6 valence electrons, it takes a lot of energy to remove electrons. So it's easier for me to gain to have a full outer shell. So now the next column says the new number of protons. Well, I'm still oxygen, so that means I'm going to have 8 protons. Now I have to figure out the new number of electrons. Well, all I got to do is count. So I'm going to first ask myself, how many am I going to gain in order to have a full outer shell? Well, if I have 6, to have a full outer shell, I want to have 8. So I'm going to gain 1, 2. So I just count to make sure I've got 8. 1, 2, 3, 4, 5, 6, 7, 8. The reason why I also put 1 on each side before I start doubling it up is so I can easily see that I have 8. I have 2, 4, 6, 8. So now I'm going to count how many electrons do I now have? Well, by adding 2 more, I now have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in my chart, the new number of electrons is 10. Now, for my ionic symbol, the ionic symbol is your chemical symbol. So in this case, it's O for oxygen. And then because I am now a ion, which means I have a charge because I have more electrons than I do protons, I'm going to put the charge on the outside of my symbol. In this case, I have 2 more negative particles than I do positive particles, so therefore it's a -2. Okay, because again, here I have 8 and 8, so this cancels out to be 0. So if I was just an atom, I would just be O. Because here I have, again, -10 electrons plus a +8. That means it's a -2. Then I'm going to determine, am I a cation or an anion? Well, anions, again, from the front side is negative, so therefore I'm an anion. All right, now we're going to go on and complete another element before you do this on your own. I have sodium. Sodium, again, atomic number is 11. So that means for an atom, it also has 11 electrons. Then I have to figure out how many how many valence electrons. So again, I'm going to start filling my shell. So now, again, you just double check 2, 4, 6, 8, 10, 11. So I have 11. So I'm going to count number of valence electrons. Again, farther shell right here is the third one. I only have 1. So I have 1 valence electron. Again, based off of my notes, it says here if it's less than 5 valence electrons, it's going to lose. So I'm going to lose. So what is the new number of protons? Again, it should be the same because it hasn't changed. The new number of electrons. Okay, so now I have to figure that out. So this is my valence electrons. Again, I'm going to lose. When I lose them all. So now I'm going to count how many electrons do I now have? 2, 4, 6, 8, 10. I have 10 electrons. So now I have 10. Again, I do the math. I have 11 positive protons minus 10 negative electrons. So therefore, my chemical symbol for sodium is Na, and my charge is a +1. I'm positive, so therefore I'm a cation. This is how you're going to complete your chart. This is all based off of knowing, going back to your notes to figure out how to complete the chart. If you have any questions, please reach out. But this is something that as you do it, you will see a pattern.